Okay, folks, the last thing we're going to look at as part of this particular video series is the so-called flash recovery area. And that's this area up here. The path to it is through under that, well, let's go up here and see the full path. Oracle XE app, Oracle flash recovery area. We, in the lecture slides and in the course text, talk about the concept of a so-called redo log. And that's basically the database's transaction log. The alert log is diary of very significant events that happen in the life of the database, failures, etc. The transaction log is a record of all changes that happen to the database. Actually, for a transaction to be complete, and a transaction is just a unit of work that we want to treat as a whole, it either succeeds or fails in its entirety. But if we were making changes to a particular table, the transaction would only be considered complete and Oracle should only come back to you and say, hey, I'm done, ready to do the next thing, once an entry is made in the transaction log. Then the transaction, once it's written to the log, written to the log which exists on disk, the transaction is considered done. If the database were to fail right after that, the data may not be written to the data files yet because for performance reasons, Oracle delays the write to the data files in some cases and tries to write things in bulk, tries to gather up a bunch of changes and flush them out of memory and into the data files at one time. But it's going to record a transaction in the transaction log as soon as things are done, and it's going to assign a new system change number to that transaction. So if the database fails as soon as the transaction finishes, the transaction is permanent only because it actually has been written to that log and there's a record in that log of the transaction having been completed. When Oracle starts up again after the failure, it's going to read through things, and we talked a little bit about that process in the last segment of this video series, but it's going to read through things and look for transactions, system change numbers, that haven't been applied to the data files. And if it finds that a data file is not consistent with the latest change number, it's going to go to the transaction log, the so-called redo log, and it's going to say, what change was made here in this particular change number that didn't actually make its way to the data files before the database crashed, and it'll go through and replay that change and apply it to the data files. So the transaction logs, the online logs, are a crucial thing to have. By default, for your Oracle XE installation, you're going to have two so-called log groups with one log file in each. The way this works is Oracle starts at one of the log files, begins to write transaction log entries to it, it fills up. Then it switches to the other one. So it may start with this one up here that I have highlighted. It's going to write through that. When that one fills up, it's of a fixed size. You can see it's about 50 megs, or roughly speaking. Once that guy gets filled with information, it's going to switch over to the next log. And it's going to go through and write that guy to completion. Then it's going to switch back to the first one up here. Oracle always has two so-called redo log groups active at any time. These particular ones happen to have a single file in each. There's one file in this group, one file in that group. In a production system, what you would want to do is have multiple copies of each file. So the way in Oracle terminology we express that is that we'd say we have multiple log members of each log group. If you had multiple versions and they would just be copies of one another of, say, this particular log, then if I had a file system problem with this particular log, I could go to one of those other backup copies. And because these transaction logs are so critical in the life of the database, we will typically, we say, multiplex these logs, which is to say keep multiple copies of them. In each log group, we'd have multiple copies of the same file so that if one of those files got hosed, we'd be able to refer to others. We would also, in a production system, create multiple log groups. Here we have two. We would create at least a third. And the reason for that is in a production system, we want to do something called log archiving, which is when a log gets finished, we want to make a copy of it and move it out to a separate area so that we'll always have it. The way things are currently set up, or set up by default in Oracle XE, these logs just kind of get circularly overwritten each time. So this log will fill up, this log will fill up, then when the second log fills up, the database will come back to overwrite this one, and the information contained in it will be lost. But if we're using a process called archiving, which I'll show you how to enable in a moment, then the information from that log is actually going to get copied out to a separate place, and then we'll have a complete unbroken history of all the changes to the database. The reason we want that is because if we have a database failure at some point and we haven't been archiving the logs, we're going to try and recover the database from some backup. And the recovery process basically consists of taking some backup of the data files we've taken at some point, and then we apply the transaction logs that we have to them. It's like replaying through the diary. And we actually remake all of those changes in the transaction log and apply them to the data files. If we want to be able to play forward from the point at which our backup was taken to the point where the database failed, we need all the transaction logs that comprise that time period. So if we're overwriting these online logs here in a circular fashion and not archiving them, we're going to break that history. Once this guy, the archiver, or excuse me, the log writing process wraps around again, this first file is going to get overwritten, this second file is going to get overwritten again in succession. So we need to set up a way to take copies of the files once a log has been filled up, so that the next time that the logging process gets around back to using that file again, the information that is being overwritten by the logging process has already been copied somewhere else. So I'm going to show you how to do that. We're going to go to SQL Plus command line, and we're going to shut down our database using shutdown immediate. Okay. I'm going to start it up again in mount mode. Remember, the phases are: the database instance starts up, things are created in memory along with the background structures, the background processes, I should say. Then the instance, the things in memory, so-called mount the data files, but the data files are not yet opened. So the instance kind of latches onto them, but it hasn't opened them for use yet. So I'm going to get to the point where the instance, the things in memory, have latched onto the data files, but they have not yet opened them up. It'll take a second or two, and you see the memory areas being created. Now the database is mounted. I'm going to do alter database archive log. Database is altered. Now I'm going to do alter database open. Database is now open. I can do a command called archive log list, and it shows me interesting information about the database. It shows me where the database, the recovery or the online redo logs are written, or where they're being archived to, the current log sequence, the next log sequence we're going to archive, those sorts of things. But this is one of the most interesting things I can get out of this command, and there are other ways to get here, but it's telling me that automatic archival is enabled. So the database is in a position to archive my logs. So ordinarily, log files would turn over because of, you can kind of see at the top there, the zoomed in view. Ordinarily, these would switch over because of database activity, but I'm going to cheat a little bit. I'm going to use a command called alter system switch log file so that you can see what happens. So let's just pretend that there's been a lot of database activity and these guys are turning over. Now there's a lot going on, and that we need to rotate logs on that basis. So go back to here to the command line. I'm going to alter system switch log file. And that's just basically said, hey Oracle, jump to the next log file. If I do archive log list here again, you'll see things have changed. Now the next log sequence to archive is jumped up to 23, the oldest one has gone to 22, etc. I'm going to do it one more time. Okay. The system has been altered again, and it has switched over, made a copy of the log files. Now I can go back here and I see that I have a new directory created. The directory is archive log. If I go into archive log, logs from today, and boom, archive copies of the logs I just switched over. So I ran through system switch log file a few times to make sure that I had turned over my logs a good bit, simulate the process of rotating through the logs, and then I ended up with this new archive log area here. And for the particular date on which I'm doing this, I have a folder, and I have archive copies of the logs in this folder. So there is a general overview of Oracle XC, its architecture, and how the things you can see on disk play into the various things we discussed in the lecture notes and the text. There's much more to be said, of course, and as we go over the various elements of the curriculum this term, we're going to delve into these subjects in greater detail and greater depth. But here's hopefully a start in understanding how what you see at operating system level relates to the Oracle processes and structures that we've been discussing in the rest of the course. Thanks a lot, guys.